Hey guys, welcome to the volume and surface area of cones video. Sorry for a slight delay on uploading this one. So to get started here, let's go ahead and talk about the parts of a cone that are going to be important in finding the volume and surface area. So we have the height of the cone, which is the vertical straight from the vertex at the top to the ground, and it's perpendicular to the ground, so there's a 90-degree angle there, as you can see in this picture. And it works very much like pyramids in this way. Honestly, you can kind of think of it as like a circle-based pyramid in a way, where it has that perpendicular height, and it also has the slant height. This L right here represents slant height, as you can see. I know for pyramids we use the letter S to represent slant height, so don't let this L confuse you. It is simply slant height. All right, and then of course R is the radius of our circular base. And those are the main pieces of information that we are going to need. So to find the volume of a cone, the formula is pi r squared times the height of your pyramid, all divided by 3. I do just want to point out that this pi r squared is not a coincidence, right? This is the area of the circular base. And in this way, this formula is not much different from the volume formula of pyramids, because in the pyramid we did area of the base times the height, all divided by 3. And this is doing the exact same thing. It's just that now we have embedded the area of a circle formula right into that formula for you, just to make your life a little bit easier. All right, so let's go ahead and try an example using that formula. So let's rewrite our formula here for fun. All right, so our radius is going to be this 2 right here, and the height of our cone is going to be 8. Oops, wow, I am out of it today. So that's our H, that's our R, and we're ready to plug in. So wherever I see an R, I will put a 2, because my R is 2. And where I see an H, I will put an 8, because my H is 8. All right, and at this point, it just turns into a calculation. You are welcome to type all of this in your calculator if you want. If you're the kind of person who likes to simplify things first, that is also fine. I am like that sometimes, so I would rather type this in the calculator than all of that. So it's really just a matter of personal preference. So if we were to calculate this in the calculator, we would get 33.51. So 33.51 inches cubed is my volume. All right, and that's it. Just remember that units are cubic whenever you're talking about volume, unlike area, which is square. All right, on to the surface area stuff. So we're going to learn a couple of new vocab words today, and these words really always existed ever since we started with like cylinders and prisms, but we really just are focusing on it starting here with the cones. So we have talked a lot about surface area, and that has been, all of the surfaces around a shape, a figure. The lateral surface area, on the other hand, is it is the sum of areas that enclose a figure. However, that does not include the bases. And I say bases like plural because I am now talking about all of these figures, like, prisms included. If I wanted to find a lateral surface area of a prism, those have 2 bases, so that's why I'm just using plural word. All right, so it's just all the space around the shape. And it's kind of like if you had a party hat, you wouldn't even count the base because the base is hollow. Kind of like that. All right, so to find the lateral surface area of a cone, this is the formula. We call lateral surface area LSA. And it's a pretty basic formula. If you have the radius and the slant height, you are in business. So to find the lateral surface area of this cone, I will just do pi times my radius is 4, my L is 5, L r. And that gives me 20 pi. If I pop that into my calculator, I will get 62.8 centimeters. And remember, because we're working with area, it's going to be square units. And that is all for lateral. Now total surface area, we already, know what that is. It's basically this same thing, right? It's the sum of areas. How did I write it up here? Yes. That enclose a figure, but this time we are including bases. And also I won't always say the word total when I'm asking for a total surface area. If I just say find the surface area, I mean total surface area. So just assume that it's total unless if I say the word lateral. If you see the word lateral somewhere, that's when there's a change there. So sum of areas that enclose a figure, including the bases. Sorry, my handwriting's real ugly right now. All right, so the formula for that is right over here. Now it's pi RL plus pi R squared. This is no magic formula. Hopefully you guys realize that this looks familiar. Pi RL was the lateral surface area formula. So basically all we're doing is we're finding the lateral surface area and then adding the area of the circular base, because pi R squared is the area of a circle. So it really makes sense like why this is the formula for total surface area of a cone. All right, so now let's go ahead and do this example problem. It's the same cone, so really, theoretically, we could just use the answer from the last problem and add on to it, but for our sake, I'm just going to do it from the start. So pi times the radius times the slant height plus pi times the radius squared. So here I end up with 20 pi, here I end up with 16 pi, because 4 squared is 16, and that gives me, I don't like that, 36. Okay, 36 pi, and then I would type that into the calculator. And again, you can type this into the calculator. It's just, in my opinion, annoying. I prefer doing it this way, but it's all just a question of personal preference. Right, and this is our final answer. This is my total surface area of this cone, of the area around it, and also the area at the bottom. All right, that is all. Go ahead and give the open math problems a try.